Good morning, students. Let me continue with Pythagoras theorem, difficult problems, and these are of mixed type by state and Cbse. Pythagoras theorem, theoretical problems. In triangle ABC, angle BCA is a right angle. Angle BCA is a right angle, right? And Q is the midpoint of BC. So here angle BCA is a right angle. Angle C is a right angle is saying. Angle C is a right angle. Next, what is saying? Angle BCA is a right angle. Q is the midpoint of BC. So Q is the midpoint of BC. Prove that Q is the midpoint of BC. Prove that what you have to prove? BC square is equal to 4 times AQ square minus AC square. Next, AB square is equal to 4 times AQ square minus 3 times AC square. So this is very important. So what is asking is triangle ABC in which right angle at angle C. Right angle is at angle C. Now prove that BC square is equal to something they give, like that's all. That is what they have given. So in order to prove this one, you need to join this one. Join AQ. Join AQ, right? Now consider triangle ABC. Consider triangle ABC. Once again I will read out the question. In triangle ABC, angle BCA is a right angle. BCA is a right angle. Q is the midpoint of BC. Q is the midpoint of BC, right? This length is equal to this length. And prove that they gave this condition. So what I am saying is consider triangle ABC. Consider triangle, join AQ and consider triangle AQC, right? AQC. See what we have to prove in mind. AQ square is there, no? AQ square AC square. So AQ square AC square is there. So that's why see what we have to prove. AQ square AC square is there. So I need to consider this triangle. Consider triangle AQ square. Apply Pythagoras theorem. So AQ square on the hypotenuse is equal to sum of squares on the other two sides. AC square plus QC square, right? So we are nearer to the problem. So AQ square is equal to AC square, right, as it is, plus what is QC? QC is nothing but half of BC, right? QC is half of BC. Suppose if this is 5, this is 5, total length is 10. So QC is nothing but, how will get this one? Half of BC. So half of BC. Now AQ square is equal to AC square plus 1 by 4th BC square, right? BC square. Now what you have to do is bring this to here. See what we have to prove. AQ square minus AC square is equal to 1/4 BC square. Now cross multiply. 4 times AQ square minus AC square is equal to BC square. First part is over. So very simple. Next one. Second one. AB square. See what we have to prove. AB square. So which triangle you will consider? Consider this big triangle. Consider triangle ABC. AB square. Square on the hypotenuse is equal to sum of squares on the other two sides. AC square plus BC square, right? So AC square plus BC square. Square on the hypotenuse is equal to sum of squares on the other two sides. AB square is equal to AC square. BC square, just now we have proved, no? BC square, what we have got? 4AQ square minus, multiply this, 4AC square, right? So AB square is equal to 4AQ square, write this 4AQ square AC square minus 4A square, that is 3AC square. So 4AQ square minus 3AC square, hence proved. So here why we are tried like this, BC square is equal to, since proved from 1. Very interesting question. It's a simple, just apply Pythagoras theorem, you will get QC half of BC, there is the solution. Half of BC is nothing but QC, therefore cross multiply. These things you should know. Since you are in 10th class, just bring this side, take the multiplication, there is the solution. Again, to do this second one, I took the first one as a hint. So in place of a BC square, I took this triangle, whole big triangle I considered. This complete triangle ABC. So AB square is equal to BC square plus AC square. So in place of BC I applied and I got the problem. That's it. Next one. ABCE is a trapezium. ABCE is a trapezium in which AB is parallel to CD. ABCD is a trapezium. This is also another important question. ABCD is a trapezium. And you know AB is parallel to CD. This already we know. In the trapezium, one pair of opposite sides are parallel. Prove that AC square plus BD square is equal to AD square plus BC square plus 2 times AB into CD. So AC square means you have to join this plus BD square, AC square. Next, join AC and BD, right? Next, here you take M and L. Draw DM perpendicular to AB. This is construction. Draw DM perpendicular to AB and CL LC perpendicular to CL perpendicular to AB. Excuse me. Right? Therefore, this, since AB is parallel to CD and also DM is perpendicular to AB and CL is perpendicular to AB means, therefore what we can say? Therefore, AB is parallel to CD, also DM perpendicular to AB and CL perpendicular to AB. This implies what? Angle M is equal to angle L, both are equal to 90 degrees. So if this is parallel to this one means if this is 90, therefore this is also 90. Sum of interior angles lying on same side of transversal is 180. So if this is 90, this is also 90. Therefore, AB is parallel to CD, also DM perpendicular to CL and angle M is equal to angle L, both are 90. Therefore, angle MDC is equal to angle LCD, both are equal to 90, right? Therefore, so in a trapezium, heights will remain same, no? Because these two are the parallel, therefore DM is equal to, or else you can, now you can consider this MLCD is a rectangle. You can consider MLCD is a rectangle. Therefore CML DC. Therefore, MLCD is a rectangle. Right? In a rectangle, opposite sides are equal. So therefore, already we know that. And one more clue is DM is equal to CM. Heights of the trapezium remain same. Heights of the trapezium. Or else you can write MLCD. Better we go with this. MLCD is a rectangle. Therefore, in a rectangle, opposite sides are equal. Right? Oh, therefore, DM is equal to CL and ML is equal to CD. These are all we should write it. Once again I will explain. Since these two are parallel lines, therefore DM heights will remain same. Altitude DM and altitude CM remain same. Therefore each angle is 90-90. Therefore it is a rectangle. Opposite sides are equal in a rectangle. That is ML is equal to CD. Now go for Pythagoras theorem. So until here it is any doubts? So I said this, consider this as a rectangle, or else heights are same. Therefore this side is equal to this side. Yeah, this side is equal to this side, and ML is equal to DC because it is a rectangle. Next. What you have to do is consider triangle ACB. Consider triangle ACB. Here it is acute angle. Let angle B is acute. So consider angle B is acute. In triangle ACB, ABC or ACB, angle B is acute. Let angle B is acute. So already we have proved that if this is acute angle and this is 90 degrees, what can you say? What can you write? AC square is equal to AB square plus BC square minus twice AC square is equal to this is a right angle and this is an acute angle. So AC square is equal to AB square plus BC square minus 2 times this complete length AB into BL. This is from previous theorem you can write. Next, consider triangle. Now this triangle is over. Now consider this triangle BDA. Let angle A is acute. So if this is acute, so what can you say again? This is 90 degrees. You can see here, this is 90 degrees. Apply Pythagoras theorem. So from previous theorem, this clearly I have mentioned. Please refer to my videos of this problem, related to this problem. Already I have proved, so we can refer to that. So now BD square is equal to see here we are coming to the conclusion. BD square is equal to, what can you say, AD square plus AB square minus 2 times this complete length into AN length. Right? Now add these two. AC square plus BD square is equal to AC square plus BD square is equal to AB square plus AB square is nothing but twice AB square plus BC square plus AD square. So BC square plus AB square, BC square plus, I'm sorry, just 1 minute, AB here it is written twice. So what are the remaining terms? BC square plus AD square plus 2 times AB square minus 2 times AB into BL minus minus 2 times AB into AM, right? Now this AC square plus BD square already we have written is equal to BC square plus AD square. So here BC square plus AD square already we have completed 90% of the problem, only 10% is remaining. Now what we have to do is take AB common in all this. What I am saying is already 90% is finished, only 10% is left over. So let us concentrate. AB take common plus 2AB, I am taking AB common. Next, what is remaining? AB minus, this is ruled out, BL minus, already you took 2 already you take AM, right? Now BC square plus AD square minus 2 times AB minus BL. So AB minus BL, this complete length minus BL is nothing but AL. This full length AB minus BL is nothing but AL minus AM. Once again I will explain. AB minus BL, this AB minus BL is nothing but AL, this part, minus this is this one. So this part is this one. So plus 2AB should take common. BC square plus AD square plus 2AB, AL minus AM, AL minus AM. This complete length minus this one is nothing but ML, right? AL minus AM, this length, this AL minus AM will give you this length, LM. Now BC square plus AD square plus 2 times AB into ML. ML is nothing but CD, AB into CD. There ends the problem. It's quite interesting. So nothing confusion in this problem. Just prove that this is a rectangle, and therefore consider these two triangles as acute angles and apply the previous theorem. So here this is from previous theorem. You can write. Now this all multiplication, this subtraction, it follows usually. Therefore ends the problem. It's a very typical question. So thank you students. Have a nice day. Please click on the blue color icon button and subscribe my channel. Have a nice day. Bye.